All right, this is section 1-3, measuring segments. So let's quickly start with a review of the vocabulary. So draw an example of each. So what is a point? Well, here is point A. Here's a point, and we'll call it point A. All right, line AB. So we're going to draw a line that contains the points A and B. And then ray, DF. It's a ray that begins at D and goes towards the F direction. All right, new vocabulary for this section, segment. So a segment is a part of a line that consists of two endpoints and all points between them. You name a segment by its endpoints. All right, let's use our vocabulary. So complete each sentence with either the words endpoint, endpoints, line, or points. So a ray has one endpoint. A line contains many points. So many, it has a whole lot. 6, a segment has two endpoints. A segment, number 7, is part of a line. Okay, so place a check if the phrase describes a segment and place an X if it does not. So the Earth's equator is not a segment. The right edge of a book's cover, that is a segment because it stops, it has endpoints. 10, one side of a triangle. Yep, it does have endpoints, it stops. Okay, so an important postulate we also use, if we're adding this to our list, is 1-5, the ruler postulate. So it says every point on a line can be paired with a real number called the coordinate of the point. So this allows us to do measurements. All right, so what are UV and SV on the number line? Label each point on the number line with its coordinate. So S looks to be in the spot where -4 should be. U looks to be where 10 should be. And then V looks to be where 14 should be. All right, so let's find some measurements. So UV. So U is at the point 10. V is at the point 14, okay? And why am I able to do this? Because this is the definition of distance. Okay, SV then would be -4 minus 14, where V is. So doing the math here, 10 minus 14 is going to give me -4. -4 minus 14 is going to give me -18. The reason I can do that is because of subtraction. I subtracted. Then I take the absolute value. So the length of UV is 4. The length of SV is 18. And the reason I can do that is find the absolute value. All right, so the segment addition postulate, it says if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC must equal AC. So this is also known to as the sum of the parts must equal the whole. Okay, so if I'm given the following, if I know AB is 5 and BC is 4, what does A plus BC equal? Well, AB is 5, BC is 4. So when I add those together, I get 9. All right, if AC is 12 and BC is 7, so the whole length here is AC. So AC is 12, BC is 7. When I subtract them, I know that AB is going to give me 5. So I added because AB and BC are the two parts. I subtracted here because it gave me the whole. So I subtracted a piece from the whole to get the other part. Okay. So in the diagram, JL total is 120. What are JK and KL? So I'm going to write each justification. So I know that JK plus KL equals JL. And the reason I know that is the segment addition postulate. Okay, now what I'm going to do is actually substitute the lengths of each one of these segments. So JK is actually 4x plus 6, KL is 7x plus 15, and JL is 120. So this is substitution. Now I'm going to simplify. So I'm going to add 4x and 7x and get 11x. 6 plus 5 is 21. So this is called simplify. I'm going to subtract 21 from both sides. And I'm going to get 11x equals 99. So this is called subtract 21 from each side. And then I'm going to divide both sides by 11, and that's going to give me 9. Okay. So let's do a similar problem here. 16, if I know that JK was 4x plus 6 and KL was 7x plus 15, use the value of x from exercise 15 to find both of those lengths. So let's find JK first. So I'm going to substitute in 9. So we have 4 times 9 plus 6. Okay, so that's going to equal 36 plus 6, which is going to equal 42. Okay, my other length here, we have 7 times 9 plus 15. We know that's going to equal 63 plus 15, which equals 78. And those are my two lengths. So JK equals 42 and KL equals 78. All right, so let's compare segment lengths in our next set of problems. Okay, so our first step here is circle the expression that completes this equation. So what should AB look like? Well, A is -2 and B is -3. So which one subtracts -2 and -3? This one. All right, D is at 10 and E is at 14. Which one subtracts 10 and 14? This one. So if I simplify AB, I get -2 minus 3, which is going to give me -5. So the absolute value of -5 is 5. And then if I subtract 10 minus 14, that's -4. The absolute value of -4 is +4. Are these two segments congruent? Well, in order for two segments to be congruent, they must have equal measurement. So we would say no. Segments with different lengths are not congruent. Okay. So the next item here we discuss in this section is the midpoint of a segment is the point that divides a segment into two congruent segments. All right, so what point is halfway between B and J? So here's B at -4 and J at +4. Well, halfway between -4 and +4 is 0. So the point F is halfway between. All right, 23, the midpoint of AE. So A is at -5, E is at -1. Halfway between them would be C. Which point divides EK? So E and K at -1 at 5, halfway between it, it's going to be H. All right, so find the midpoint of each segment, then write the coordinate of the midpoint. So the midpoint of AG, A to G looks to be D, and that coordinate is -2. All right, the midpoint of DH looks to be F, and that coordinate is 0. And the midpoint of AK is also F, and that is 0. All right, so find the coordinate of the midpoint of each segment. So a segment with endpoints at -4 and 2. So here's -4 and 2. Halfway between them would be -1. How about between -2 and +4? I think halfway between it would be a +1. So if we put these together, we actually can develop a formula. So what are we doing here? Let's take a look at this one. If I have -4 and I add 2 to it, I get -2. How can I get 1? Well, halfway between it, so I divide by 2. All right, same thing if I do here. -4 plus 4, and I would divide by 2. I get 2 over 2, and I get +1. So we could develop a formula by adding the two coordinates and dividing by 2. So that is the formula to find the midpoint between any 2 points. Okay, so let's use that. So here's a line segment, and I define two lengths. TU is 8x plus 11, and UV is 12x minus 1. All right, so let's fill in this little proof here. So we have TU and UV. So TU is 8x plus 11. UV must be then 12x minus 1. All right, so the first thing we're going to do is add 1 to both sides. Okay, so I'm going to copy down to 12x minus 1, and I'm going to add 1 to both sides. Then we're going to subtract 8x from both sides. So I'm going to do that, and I'm left with 12. And then I'm going to be left with 4x. And then I'm going to divide by 4, so I'm going to be left with 3. All right, now I'm going to take that 3, and I'm going to substitute it back into my equation. So 8 times 3 plus 11, that's 24 plus 11, that gives me 35. So what did I do? I substituted in 3 for x. Same thing for UV, so 12 times 3, which is 36 minus 1, we get 35. Okay. So TV equals TU plus UV, that's the definition of midpoint. We know that TU equals 35, and we know UV equals 35. When I add them together, we get the total length to be 70. All right, do we understand? Name two segment bisectors of PR. All right, underline the correct word or symbol to complete each sentence. A blank may be a point, line, ray, or segment. So a bisector may be a point, line, ray. So something that just divides a line into two parts. The midpoint of PR, so here's PR, looks to be Q. The line L passes through the point Q. So the bisectors of PR are point Q and line L. And that's it for this section.